Good Monday morning, guys. Michael Clark here with BAMWX.com and the weatherporthole.com. We're going to go over the latest thoughts on the long range forecast, and I'm going to spend some time today discussing how rainfall projections work with computer modeling. Okay, that's very important. There's so much out there. I see just blind postings of rainfall maps and just this model and that model and whatever it says down to your specific point is what you're supposed to get. And the way that a lot of the time, the way these maps are taken are incorrect, and we have to make sure that I want to make sure that you're reading these maps properly and you know exactly how they're designed and what they're made to do. So I've consulted with our own Dr. Ryan Maui, and I've talked to him this morning, and we've come up with some images on to explain this process to you. Because there's so much going on about modeled rainfall and the model maps, and I want to talk about it. So we'll get into it here in just a second. This is our intro slide for a morning report sent out to our clients, and we're looking at a couple of things this week. All right, first and foremost, possibly a heavy rainfall threat or cluster of thunderstorms in west central Iowa where it's needed. Now, that's in our days 3 to 7 hazardous weather outlook. Very important that we kind of keep an eye on that. And then we've got some cold fronts coming up, possibly here as we're getting into the month of August. The August pattern, we're going to kind of dissect that as well. A lot of it hinging on just the erratic Southern Oscillation Index, the SOI. So I'll get into that in just a second. But let's take a look at this real quick. Let's take a look at the trends and looking at some of these models. And comparing previous runs. This is the European model forecasting the EPO, the Eastern Pacific Oscillation Index. And these are all the various runs. Each time, each different color is a different run. So, obviously, we've had a huge problem in the EPO forecast. Anywhere from -2 to as much as +3 in the latest forecasts. And the model struggling immensely at nailing down the Pacific pattern, and even out beyond 5 days. And we believe a lot of this is due to the background state of the atmosphere, the differences in the SOI and the angular momentum, and the all these fancy terms, all these things going on in the Pacific Ocean. But you look at this, and you look at the trend in these models. I want to show you the GEFS, the same thing. It's awful. They're just completely whiffing on the Pacific pattern. So as long as this continues to happen, full transparency, it's very difficult for us to come up with a good handle on things really beyond 5 to 7 days. In fact, the charts for this week from last week's computer modeling are horrible. And it's because of this complete whiff in the Pacific pattern. The EPO is a significant teleconnection. It really has a lot to do with our weather here in the U.S., and so it's really, really wild to see this. Now, if we want to look at the latest forecast and want to look at all of these models and just look at what they're saying for the EPO right now, they have all gone positive. But it's when they start getting out into this range, where they start to, in the extended, where it muddies the waters, as the models start to see blocking develop again. So it's been a problem, all right? And until we can get a good handle on these, I really think the lack of commercial flight data and things going into the data going into the weather models, I think it's really significantly impacting the accuracy of the model. And so we have to just preface that anything beyond week 1 is risky. It's tough to nail down. I'm not going to sit here and pretend like I have all the answers, because I just don't. It's just that simple. I don't have a magic 8 ball, or I'm not super special compared to someone else's analysis, Rainfall over the weekend. We've had some decent rains right over the last 72 hours. Boy, South Central Illinois, East Central Illinois, West Central Indiana got pounded with rain. And I know some folks down here in southwestern Indiana really needed it. Areas that continue to really hurt here across Ohio, central, northwestern Ohio, northeastern Indiana, places here across western Iowa, eastern Nebraska. Some rainfall is needed here. Okay, it's needed. Now, before I get into these rainfall maps, I'm going to show you these maps zoomed out. On the left is the NOAA HRRR rainfall forecast out to 18 hours. Okay. On the right is the GFS rainfall forecast out to 24 hours. They're both showing generally the same thing. What I've done is I've had Ryan, Dr. Malley here, plot our grid points, the resolution at which these models can see rain. On the right, GFS, global model, global forecast system. On the left, HRRR, high resolution rapid refresh model. Okay, updates every hour. Okay, this model here on the right updates every 6 hours. This one goes out to 384 hours. All right, this one here goes out to 18 hours. So these models are used for, excuse my horrible writing with my mouse. These models here are used for obviously different things. Short-term forecasting versus, longer term. I'm going to zoom in. I want you to see all these tiny little cells, these tiny little grid points here. This is the 3-kilometer grid spacing on the high-resolution rapid refresh model, equating to 1.8 square miles per each grid. Okay? The GFS model here on the right is entirely different in terms of its resolution. Okay? Its resolution is drastically higher. Okay? Or drastically, I guess you could say drastically lower. There are big differences in what its spatial resolution is at 13 kilometers versus the 3-kilometer HRRR. So what happens is your rainfall projections are bulkier. And what I mean by that is that the model doesn't have the ability to make it localized looking like this HRRR model on the left. For example, look at Brownstown. Okay, on this image in the HRRR, the northeastern section here of the county is essentially looking at lower rainfall risks here. But on the GFS, it's a widespread half-inch of rain. Now, I've done some more research. In the southeastern portion of Indiana, according to stats.indiana.edu, if we're looking in essentially this area right here, there are 143,000 homes. If you zoom in all the way down to this actual level here, all the way in as far as we can go, do you have any idea how many backyards are in each grid? Okay? Hundreds, if not thousands. There are thousands of people in these grids, in these each spot. So taking that rainfall estimate down to one spot is not possible, even with the highest resolution computer. You go over here to the GFS model, which is what everybody posts all the time, and look at this. This is the grid. Okay? So, yes, there can be some smoothing and some things going on, but overall, you're saying over a very large area with a lot of people that everybody's rain gauge should read 0.52. That's just not how this works. Okay? These models are made for generalized ideas, but for convection or rainfall in a model, all of the components of the model have to work together, including radiation, land surface, microphysics, convective parameterization, friction, drag, everything. It all has to work together. Okay? It's very, very important that you understand that when you see a model, if one of the things I just mentioned don't line up with the other, the model is at serious risk at being incorrect. And you can see how our high-resolution short-term models have the ability to be much more accurate. Doesn't mean they always are. But you can't look at these maps, guys, on the right, especially the GFS, and go, 7 days out, I'm supposed to get 0.77 inches of rain, and if I don't get it, the guy who posted it and the model is wrong. That's not how this works. If you wanted to look at this in general, what you should do as a forecaster is look at it within 25 miles of a point. And you should say, generally, this area here could get 0.3 to maybe a half inch, but some places may only get 1/10. Some places may not get much. And if we look over here in the HRRR model, that's exactly what's happening. Some places aren't going to get any rain inside this little 25-mile radius. That's how you should be looking at this. Weather models and forecasts are good to about within 25 miles of a point. Okay? Remember, everything has to work together. The ECMWF on their next upgrade for next year, they are addressing how these components can work together rather than continually improve them separately. And that's why some things are fixed, but all of a sudden something else important gets worse. And so it's very important you understand this when you see these weather maps being posted. Hopefully I can help you understand it. Here's a 3-kilometer high-resolution NAM model over the next 60 hours. Let's move forward. This is going to be a long video. Okay. Here's a look at the projected rainfall pattern, convective in nature, which means the model's not going to nail it down to the spot. It's going to tell you that generally, over the next 2.5 days, it's going to be stormy in here. You might get 3 inches here, but the 3 inches doesn't happen there. And that's the differences in the convective modeling. It's giving you the generalized idea that in this area, within 25 miles of a point, it could be stormy. Regardless, the next 2.5 days, it's stormy in the central U.S. Okay? Looking at days 1 to 5 and days 6 to 10, using the European model and the GFS. European model, days 1 to 5 on the top, 6 to 10 across the right. So here's Euro. We're doing Euro on the top, GFS on the bottom. Generally, a pattern we agree on. The European a little bit further north with the corridor of the activity, as the GFS is a little bit further south. Okay? So the ideal situation in something like this is to take a blend of the two, and that's what we're going to do. I'm going to show you in just a second. The European struggles with convective rains in the 6 to 10. The GFS does better with convective rains. We'll side with the GFS in the 6 to 10, continuing to hint at scattered thunderstorm chances here in the 6 to 10 day. All right. The blended outcome from everything here, looking at our blend of models, suggests this look. And again, we are watching for the potential at some beneficial rains here. Okay. So that's good in west central Iowa. We are watching that. We'll fine tune in the days ahead. But nonetheless, it's not a bad looking pattern the next 7 days for rainfall across the central, across all the grain belt, really. The area that needs it, that's still looking to kind of be on the outer edge of the periphery is here. You know, northeast Indiana, you see 3/4 of an inch of rain, but refer back to the model discussion I just had. Okay, generalized idea. When you look at the departure from average, the generalized idea, it's drier here. And it's wetter back in through here. And obviously in the North Plains. This is the percent of normal next 7 days. Okay. Week 1, week 2 precipitation outlooks. All right. Again, generally favor an active pattern in the central U.S. and equal chances in the eastern belt with a below normal favor here. Below normal side of the table will favor in the eastern belt in the mid-Atlantic, as they'll continue to run pretty warm. And we also need to watch down here for the potential for tropical activity in week 2. All right. Temperatures 1 to 5. Quick look here at a blended model average. Everybody's going to pretty much run above average, with the exception of a tad cooler in the Great Lakes, cooler into the deep south, but very warm into the east and the mid-Atlantic. And then in the 6 to 10, should get a little bit warmer. Everybody's going to run about 3 to 6 degrees above average. Isolated areas running a little bit warmer, probably especially where it's drier in the eastern Corn Belt. And in late July, that's warm. It's going to continue to run warm with nighttime lows and daytime highs. Week 1, week 2 temperature forecast. We went a widespread 3 to 5 degrees above average in the east. And a lot of this is due to the pattern that we're noticing, just the models just having a horrendous time forecasting and verifying. We do believe, though, that July ends up the warmest on record for cooling degree demand, energy purposes, with an estimation at 413 CDDs. All right. We do believe the warmer pattern begins to break down the second half of the week 2, though. Okay. A lot of the warmer days are in the first few days of the week 2 forecast, but we anticipate a strong cold front probably develops between the 30th and the 1st of August to lead to a cooler shot of air as we work ahead. And that's due to the Southern Oscillation Index. Again, these big swings down to the negative territory gets us into the El Nino flavors of the atmosphere, simply put. And we are forecasting probably a bigger cold front and a breakdown in the heat as we open up August based on that method. The CFS is trying to see it. The 16 to 20 day forecast from the CFS is trying to hint at some intrusions of some colder air, possibly a front in here that may work in. The models struggle to see this, but we do believe it is a possibility going forward. The last thing I want to talk about today, and I'm going to wrap it up. We're only going out 2 weeks. I don't have any interest going out any further, but we do need to watch what's going on in the Gulf of Mexico, as some indicators are the tropics could heat up, especially in this area here. We need to see where they're going to go further down into the forecast getting into next week. Guys, that's all I have. Thanks so much for checking out our video forecast. Again, if you have interest in our product, please feel free to, I'm not sure why I can't go to my own website. Okay.